Mathematica is a wonderful encyclopedia of mathematics. It's designed for both teachers, students, or lovers of mathematics. Let's browse to Wolfram Alpha and search for what Mathematica is. Mathematica is an all-in-one computation and visualization system, development environment, and development engine. It is used across diverse technical fields including engineering, science, and financial analysis. Let's talk a little bit more about its use for teachers. Teachers can use demonstrations to allow students to visually change aspects of a graph, chart, or picture. Let's watch a short video on exploring graphic ideas using Wolfram Demonstrations project.
Let's look at specific question submitted to us by another educator. It reads, I'd like to see some examples of how to make professional-looking graphics that would be applicable to high school and undergraduate mathematics courses. For example, a function of one variable with a few rectangles under the curve to help a student visualize a Riemann sum. While this question goes probably a little bit beyond the scope of this workshop due to its technical nature, we still can try to address it by looking at the related applications, the Wolfram demonstration project. To do that, we simply need to select the subject of the question, copy it, go to the demonstration project and paste it in the subject line. When we do the search, we come up with quite a few applications, and one of my favorites is called Comparing Basic Numerical Integration Methods, submitted to us by a user called Jim Brandt. And the reason I like this one is because besides the obvious rectangle subdivision, which you can obviously see on the picture, it also provides with many methods, left sum, right sum, midpoint, trapezoid, and Simpson methods, and also provides you with neat tools, like for example this magnifying glass, which allows you to zoom in on the features when you have too many rectangles, and you can change the curves. And as you change all the settings in these applications, all the areas and approximation are computed fluidly, live by CDF running Mathematica kernels right in the web browser. And we can easily appreciate this beautiful educational graphics that is available for free to use as it is, or adopt its code for your own interactive application. Let's now go back to our search screen and see what kind of other applications we can find. We can see that not only two-dimensional figures or Calculus 1 are represented, but also 3D graphics is here, representing Calc 2 and 3. For example, this demonstration submitted to us by user Jason Harris demonstrate how to approximate shape of a sphere by methods of disks. You can change, for example, opacity and add the shapes that you're trying to approximate, which demonstrate the beautiful capabilities of Mathematica's three-dimensional graphics. One of my favorite ones is called Volumes of Revolution Using Cylindrical Shells, submitted to us by user Steven Wilkerson from Towson University. Why I like this one especially because it starts from two-dimensional graphics, and you recognize the Calculus 1 subject by trying to fit a simple curve. Then you have ability to circle a swipe angle, to understand how you build the rotation figure from this, and then you can also add the number of segments and the visualization through cylinders, which has opacity. And you can easily see how the Calculus 2 is getting connected to Calculus 1 through this beautiful visualization. So please, if you search for some sorts of inspiration or even source code that you can reuse, visit our Wolfram demonstration project, and you will find here beautiful examples of two-dimensional and three-dimensional graphics.
That video was more advanced than the topics of our wiki. A demonstration on profit and loss, which pertains to this unit, can be found by searching the Mathematica Demonstrations project page shown here. Let's type in profit and cost into the search bar at the top of the page. How about this competitive model shown here? Here we can see several sliders pertaining to price, cost parameters, and fixed cost. Now this is more advanced than our wiki demonstration, but these demonstrations can be downloaded and adapted by changing the source code, which can be found on the right-hand side. You can see as I change the sliders, the graph changes as well as the profit-cost calculation. What happens if I make the price smaller and the cost greater? You can see that my profit has gone into the negative, and this red square appears on the graph. Allowing students to use this demonstration can help them see how parameters in a function change the graph and subsequently the profit or loss.